So in today's class, we're going to discuss about functions again. I hope you're really okay with the functions in Python, right? Do you want me to cover the basics of functions again? Am I audible?
Yeah, for me it's okay.
Let's see. Yeah. Let's see how far you're okay with the functions. So if we have a simple function and I call it out, I just get a print of hi. And when I print this out, I get another extra thing called as none because there's no value assigned to it. When I return something called an integer value of 3, let's say, your return value will be 3 instead of none. If I say hey, the return value will become hey now. So let me just do this thing. Let me just pass another outer function. Let's say name is Scarlet def. Let's say inner func print our fav address is name return other function. Let me make it as outer. So when I do this and then print my outer function, nothing is displayed, right? Because inner function is not called at all. So when I call inner function and then say return outer function, oh sorry, got issues with this. Nothing is printed out. So when I say a is equal to function of and I try to print this one, still nothing is printed. So when we have to, oh sorry, give me one moment here. That was weird. So we just define an outer function and then we declare a name and then inner function to return name, which should return the name when inner function is called. So yep, we got this. So a is equal to function call and then call this a. It says string object is not callable. So what's going on here? I'm just writing a couple of steps going on irrespective of your response. So are you really catching this? What's happening here and all? I just declared a function and then I nested it with another function and I returned some value. End of the story. And in the return of outer function, I called this function called inner function. So I believe that you are okay by now about the return statements and print statements of the functions, right?
Yes.
So um, so what's happening here? You're understanding it, right? So when you assign a is equal to certain function, will it really work? So how it is working? can I assign like this, first of all? Obviously, it's because the script is working fine.
Yeah, you can, but the only thing is print A, it's only returning the scarlet. That means the outer function, the result of the outer function, only the name variable is assigning to A.
Um, okay, but why did I get this one?
The first one?
Yep. But can we really assign a variable, a function to a variable, just like a value? I'm treating just like this, b is equal to 2. Can I do that? Seems like you forgot already, so let me repeat it again. A function in Python is called as first class function. A first class function in the sense can be treated as an object, as a regular object in Python. So first class functions or higher order functions are one and the same, and they can when you say a function in a programming language is a first class function, it means that you can treat it as a variable. Variable in the sense there are three qualifications that needs to be met by a variable. If at all, it has to be called as a variable. First thing, you can assign a value to a variable. Second thing, you can pass it as an argument inside a function. Third thing, you can return that variable as a return value of a function. Let's just go ahead and see. So v is equal to 2, print v. This is a variable. Def function is equal to, and then return v. Then execute this. Nothing has happened, but when I print the function, the return value is returned as v. So you got this right. So you can return it as you can return this variable as a return object of a function, and you can also pass a variable inside a function, just like that, right? These are the three qualifications of a variable. So when I say that first class function meets the qualifications of a variable, let's go ahead and try that. 1, v is equal to 2, which is nothing but a is equal to some value, right? We are assigning this function to another variable. So it's possible. The assignment of operation is possible with functions. Agreed? Any
Yes.
doubts?
Yes. No.
Mm, Sushmita, Prasanna, Sushanti, you're okay, right? You agree with this, right? The first property.
Yes.
Yes.
Okay, cool. So, and if you look at this one, so when I talk about these three properties, when you club these three properties, you'll get a beautiful thing called as a decorator. So we will discuss about what a decorator is. So for that, you need to be very attentive for these few minutes. And then we returned a variable as a return object of a function, right? So same thing we are doing here. So it is possible. And the other thing that is left is passing that function as an argument, right? So let's see. Instead of declaring a variable like this, I'll say name, and then I'll pass here. So you got this. So the fans of Anne Margaret will return a value where my favorite actress is Anne Margaret, and Scarlett's fans will return this one. So this is just passing a variable as an argument, right? If you just don't understand, just stop me. Stop by, otherwise you will not understand for the modules. You are clogging up somewhere else. So now I'll just do one thing. Define some dummy function. Print. We are inside dummy function. So when I call this out, got an error. Dummy is not different. Okay, sorry. When I call this out, this is what we got printed out. But I'll just cut short the scene. Not to make sure that you're confused. I mean, to make sure you're not confused, I'll just name it as decorator. And I'll just name it as a wrapper. So outside functions are now named as decorators. And inner functions are now named as wrapper. Now, instead of calling this, I'll just say decorated is equal to decorator of dummy. Let me just comment this out. So what I did now is I just passed this function called as dummy as an argument to this decorator. Right? Till now, name is nothing but a variable, but now it's a function. Kind of confusing, or you're okay with this? Can we move forward?
Explain it again.
Yeah, sure. Okay. So what will be the output? What will be the output? Prasanna, what will be the output here?
A is 2, B is 3.
Exactly. So by this, what did you understand? Whatever you pass it as a first argument, it will be assigned to A. So it really doesn't matter about the naming convention, right? So it's a positional argument. It passes on by position, right?
Yeah.
So now what I will do is just declare another function. Or C maybe, just to clear up the things. So did you understand this one? So when I try to print C here in this statement, I'm trying to print C, right?
Yeah.
Am I trying to print C or not? Or B? What am I trying to print?
Print C.
But you see as B. Did you understand this? What is it going on?
No.
Yeah, so that's what I'm speaking about. When you say 2, it's a position argument. The first argument is assigned to A, and the second argument is assigned to B, right? So even though you're addressing this as B, the argument that belongs to B now is C, right? So there is nothing called B declared here in this entire program. So it's a positional argument. You're passing C in place of B. So whatever the manipulations you do for B, it is just happening for C. Got it?
Okay. Yeah.
Yeah, so now when I say return here, now we got a value for this, right?
Yeah.
So you're passing a function as an argument here.
Okay.
To this part you understood, right?
Yeah, understood.
Yeah. Cut the scene short. And then I just have this one again. Do I have any other thing? Yeah. I uncommented it now. I just named it as a decorator wrapper. That's it. Nothing much. And I am passing a function just like I'm passing here. But this is another function which is not nested, a simple one. Again, this is just a nested function. That's it. There's no much difference. Right? So here I have a print statement, but here I have a print and a return too. That's another thing. So I just complicated a bit. That's it. There's no much difference. And I'm passing the same thing. Here what I did, I passed C, which is a function, as an argument inside another function, right? So I'm passing dummy, which is a function, as an argument inside another function. But here, this function is nested. That's it. Understood?
Yeah.
Yeah. Now what is happening when you call this function? It is in turn calling its decorator, and again definition of a wrapper, and then returns wrapper. When you say returns wrapper, then there you are making a call of a function. And then it gets executed and it returns the name. This one will be stored as a memory for this wrapper. So when I execute this now, what will happen? First thing is, my favorite is, the name, it just get passed off. Yeah. So this is what happens. To make it more clear for you. So by the way, this attribute, did we discuss about this attribute? Underscore name, underscore. Yes, no? Okay, I think we discussed about this. So as you can see, underscore name underscore gives you dummy. Again, I'm gonna ask you this question. So did we discuss about this?
Yes.
Oh, I do not remember. Okay, fine. So you know about underscore name underscore. What is it? Did you remember a bit or a piece of what we discussed, Prasanna?
Sorry, I didn't get you.
No, you told that we discussed about underscore name underscore, right?
Yeah.
What did we discuss?
So if name equal to main, when we call the main, it will return that value.
Oh, okay, fine. Cut the scene again. Go back to your previous example. Underscore name will return the function's name. So if I try to print simple dot underscore name underscore, this should be the function name. Now execute this. It says simple. This should be the function here, right? So now in a simple program where you're not using any other function, except main, there in that case it will be equivalent to main. So this, speaking of it, in a simpler case, it will just return the function name which is associated with this. So now without wasting much time, I will just comment this out. So it says dummy is the name of this name because we are passing name, right? So when I try to execute this one in here, now it gets executed and it says we are inside dummy. So now when I say this, it says none type. Okay. So when I just return the wrapper and then called it out, or yeah, you got this these two print statements from wrapper and dummy, right? So now again I'm asking you, I'm requesting you, just point me out if you're not understanding. So I just commented out these two lines and I say decorator dummy off. Why would I say sound DUMM every time? So the output is same, right? I mean, when I execute this alone, it returned me the same thing as when I executed with decorator on. But when I off this decorator and I run it, the output is changed. It is entirely related to only this. So this is basically a decorator. Decorator in the sense, it decorates the other functions. So how did it decorate the other function? If it did, what is that function that got decorated and what is the decoration it has done for that function? Before going further, are you guys clear?
Can you explain one more time?
Yeah. So Prasanna, how about you?
No, I didn't get you. Can you explain it again?
And Sushmita,
Yeah, it's good.
you're okay with this?
Yeah.
Okay. What did you not understand here, Sushanti? I mean, what part of it? I know for the decorator part, it will be confusing, but I just wanted to emphasize more on whatever you were missing.
So if you're targeting the decorator,
Uh, sorry, I did not hear your question.
can you explain the decorator one more time?
Okay, cut short. Fine. So what we did here is we are passing a function inside a decorator, which is another function, and we are declaring a nested function, which is having a return statement where our original function is called. Original function in the sense whichever we are passing into the dummy, whichever we are passing as an argument. So we are playing around with the function calls, simply speaking. And one thing we are trying to achieve, what is it? The property, the full-fledged property of a function in Python. It means there are three properties we said, right? One, assignment; two, argument passing; three, return. So by covering all these three aspects, if we write a code, it is called as a decorator. So the lively example is this one. This decorator will have a return value, a function that is passed to a return value, a function that is passed to an argument, and a function that is assigned to another function, to another variable, sorry. Right? So when we club these three things, what we get is nothing but a decorator. So when you execute this decorator will implant its logic to this dummy. So what it gets implanted is another thing that we are going to discuss now. But before that, till now, what is being called at what point of time? Are you clear? So when I'm calling dummy, what really happens is it executes decorator first, goes on and passes on this dummy to this name, and then there is a function, and then print statement. That's why you got a print statement. Sorry, and then there's a print statement, but this function is not called, right? So, and then when you say return name of, that's where it gets called to dummy, because name is nothing but dummy, right? So there's a print statement. So it stores this print statement in this return value. But when that will happen only whenever we are trying to print out this wrapper function, right? That to that much, are you clear?
Yes.
Yeah. Whenever you are trying, this value is stored as a return value of this function. But until and unless you call this wrapper function, it will not be printed. That's why we are inside dummy is not yet printed. And then it gets to return wrapper. This return wrapper, when you say this, we are calling this now. So it goes on to this call and then prints this, which is having a print statement, and then the value of this wrapper. That's how you got my favorite actress as first, we are inside dummy as next. Did you kind of understand?
Yes.
Rest of the folks?
Yes.
Yeah, so sounds good. And I'll just do one more thing. I think I don't need this now. Def, it's just simple. A comma B. Print A is, B is. By the way, this is very important in interview perspective when you are into application development majorly. But still, for sophisticated roles or experienced roles, decorators are must, because it enhances the functionality for Python. So 2,3. When I execute this, I get it, right? But here, can I apply this decorator to this? So well and good. It got this output return, right? So now I'll just pass it as an argument. It says wrapper takes 0 positional arguments, but 2 were given, right? It is working only when there are no arguments given, right? So for this to handle, so it's like we are decorating this dummy function and it is working because there are no arguments that are passed in this wrapper, right? So when you are trying to decorate an object with arguments, we are getting in error about this positional arguments. So it doesn't work like that. So how to handle this? Whenever you want to pass arguments dynamically, so it's like, for example, you have a function print a comma b, 2,3. It goes okay, but if you want to dynamically change these arguments at any point of time, we use something called star, and then so you got something like this, right, in the output. So when I try to pass this, you got this, but when I change these arguments, you still got it. But when I remove the star and pass a comma b or a, it says It takes one positional argument, but we gave 3. So in order to bypass that, we just need to add star. This is called positional arguments, args we say. And keyword arguments is another thing that comes with double star. But you should not use it like star A, but we should use it like args because it's just a standard convention. When you pass it on like this, let's see. So when you pass it on like this one now takes any number of arguments. So you can also pass like this. Any doubts here? I think things are clear, right?
Mhm.
Is it yes or is it no? I don't understand the.
Yes,
Yes, yes.
clear.
So when I pass keyword arguments, let's say name equal to Jolene. So let's say this. You got a dictionary, right? Keyword arguments are nothing but a keyword and an argument. So it's like a key value pair. So it by default forms a dictionary, whereas args forms tuple because there is no keyword key and a value for that. That's just a tuple, which is consisting of only values. So we're going to make use of this thing here. So wrapper demands no arguments here, right? So we'll just pass args, kw args, args, and kw args. So when I pass this now, I got an error. So for keyword arguments, it should be like this. So now you got this as well. Oh, sorry. Yeah, we got this executed as well, right? So this is just an escape thing. Basically, why we use decorators? By the terminology that I said that we can decorate other functions, how are we doing it? Except for this single print statement, I don't see a single use of this decorator. We are getting an additional print statement here, right? So apart from that, I don't see anything, but why do we complicate like this kind of a block here? So the answer for that question is, I'll just remove this off. I'll just import time. Let's say this dummy, I'll remove it for now. And let's say square of a number. I just want a program which gives a bit of weight for my RAM. That's it, which takes a lot of time. So I is equal to I into I per I in, let's say, so okay, fine. I think this should work. So instead of dummy now, I'll just use square. So when I decorate it, it works fine. What happened here? Okay, we have taken off this print statement. Sorry, I just imported time here. Start is equal to time dot time. I'll explain what this is all about. And what I'll just do is print, okay, result is equal to name of args, keyword args, stop is equal to time dot time, time lapse, let's say is equal to start minus stop. So return something called result, and also print the time of execution for this function named is. So what is the function? It's name, right? Is it name? Yeah, it is. I think so. Yeah. So when I do this now, it says 0. So what I will do here is, okay, sorry, I don't execute this. This is the return value, right? Okay, this is a return value and result is nothing but this one. So ideally it should get printed. But are we printing anything in this case? Oh, sorry. Print E. We're not printing anything here. So this is the return value. Yeah, well and good enough. So let me just burden the system more. Hey, I'm speaking to myself or you guys are following? Still it shows 0.0. So what I'm saying is I just declared time and then I executed this function here and then I just declared another time. So that time minus this time, maybe probably I should do, it's showing in nanoseconds, I mean microseconds. Still not helping. Okay, I'll just burden something more, something else. So now, oh, okay, the formula might be a mistake. So it's stop minus start, right? So when I try to, okay, you're getting distracted by this. So when I try to execute some 1,000 elements, okay, fine. I'll just comment this out and then I'll just say print this. So the time of execution is 9.9 seconds and then print this is logic inside square, right? So your function is getting executed, or let's say I'll also print this one for time being, and then you're getting the time of execution as well, right? So if you want to print the time of execution of every block, every code block in your program, you need to write that declare import time and blah 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 like that, right? So instead of that, you can decorate this function with timing. You can also decorate this function with logging option. So logger is another point of discussion for us. We can discuss it some other time, maybe tomorrow. But I just wanted to show you how a decorator works and how it decorates. Is it confusing or clear?
For me, it's good.
Clear? Good.
It's clear.
Okay. Yep. So if you're all clear with this, then I'm pretty much happy that you understood decorators in first shot. But if not, please do practice it. It's a bit confusing, I know. Maybe I may have confused you, but I can say that this is far better way that I can explain about decorators. This is the best I can do. Even if you Google it, you'll not understand decorators at all. So I just wanted to do a post-mortem of every block in this decorator, which we had gone through in this session now. So if at all there is a piece of code that you did not understand how decorator operates and all, you can let me know. Otherwise, can you continue for 5 more minutes?
Yeah.
Again, just stop me off if you're already like occupied with too much of content. I just commented this one and I did not change anything. I'm saying class decorator. I'm importing something called object def initializer. Just forget about what all these are for now. Let's say some function self.func is equal to func. Soon we are going to start oops, so there's no problem for you. Call self args keyword args. So return, okay, import timing start is equal to time dot time result is equal to here we call it as function, right? Self dot func of args comma keyword args time lapse is equal to start, sorry, time dot time minus start. Maybe I need to do a multiplication over here, and that's okay, fine. And then return result. So when I do this, sorry, it shows an error, and this is because of this. So when I do this, it returns the same thing. Oh, sorry, I did not print the time lapse here. Print time lapse maybe. So you got the time lapse here too, right? So let me just grab this one. Print. Instead of name, now I need to use self.func. So this is about square again, and we got the time lapse. Previously we did into 10,000 here, and we did not do here. If we do it here, so let's say into 10,000. So this will be kind of looking like a valid value, which we encountered previously. So there's no difference at all, right? So this is one way of implementing a decorator. It's binded with oops. So that's about this. This is an exact replica of whatever we have created using functions. Yeah, so that's it for today. I'm just gonna stop this recording.